out, Isotopes are not just a baseball mascot from The Simpsons. You're all probably so young that you've never watched The Simpsons. So that joke, reference, thing didn't land. That's okay. I don't actually need to feel relevant. We're still going to talk about isotopes, so it doesn't matter. Isotopes are atoms of the same element. So if they're the same element, they're going to have the same number of protons, but there's going to be a different mass number for one isotope versus another, because there's going to be a different number of neutrons in the nucleus. Remember that the mass number is the number of protons plus the number of neutrons. So if the number of protons stays the same, but the number of neutrons is changing, then you're going to have a different total, which means a different mass number. That's what we call that total. So the atomic mass on the periodic table is actually an average of all of the occurring isotopes for that element. We're going to talk about that calculation later. But for now, just be aware that, remember again, mass number is different than that average atomic mass that's on the periodic table. And the reason we have two different numbers for those masses is because of isotopes. So you can see in this picture, there's a hydrogen 1 atom, meaning it's got a mass of 1 because there is just 1 proton there. So there's your mass number, 1. There's also a hydrogen 2 atom, meaning there's 1 proton and 1 neutron. Add that together, that's 2. So you've got your mass number of 2. There's also a hydrogen 3 atom. You've got 1 proton, 1 neutron, and another neutron. Oh, look, that adds up to a mass number of 3. 1 plus 2 is 3. So these are all hydrogen. And I know they're all hydrogen because they all have exactly 1 proton. And if you look at a periodic table, the only element with just 1 proton is hydrogen. But just gonna erase all the scratch work. The thing is that even though they're all hydrogen, they have different masses because the number of neutrons in the nucleus can change without affecting the chemical properties of the atom. It only affects the physical properties such as mass. Okay, there are 2 ways you can write isotopes. You can have hyphen notation or nuclide notation. Hyphen notation, you put the name of the element, you put a hyphen, that's why it's called hyphen notation, and then you put just the mass number. So like carbon hyphen 12 means a carbon atom with a mass of 12. Another example would be like nitrogen hyphen 15. That would be a nitrogen atom with a mass of 15, or like oxygen hyphen 18. Those would be mass, that would be an oxygen atom with a mass number of 18, where the protons plus the neutrons equals 18. You can also write this in nuclide notation, where you put the mass number on top, the atomic number on bottom, and then the symbol of the element next to it. This is really similar to some abbreviations we saw the other day, where like we wrote proton with a mass of 1 and a charge of 1, or we wrote neutron with a mass of 1 and a charge of 0, or we wrote electron with a mass of 0 and a charge of -1. This is actually a really similar notation, except instead of just charge overall, we're putting specifically atomic number as that bottom number there. So like carbon 12, carbon, if you look at your periodic table, has atomic number 6, so there's 6 protons there, and then the 12 that was the mass becomes your top number over here as your mass number. So we could do it for the nitrogen and the oxygen examples that we were just looking at over here, where I can take that 15 was the mass of this nitrogen, I can put that 15 on top. I can take that 18 was the mass number of this oxygen, I can put that on top. To figure out those atomic numbers, you're gonna have to look at the periodic table. And if you check, whoops, if you check, nitrogen is atomic number 7 and oxygen's atomic number 8. So there's some guided practice here. We're going to draw and kind of compare contrast these isotopes. Carbon 12 and carbon 14 are isotopes like of each other. That's sort of how you say this. They are isotopes of each other. They are both carbon. Because they are both carbon, that means they have to have the same number of protons. That's the definition of like how you know which element is which. If it's carbon, it has to have a certain number of protons to be carbon, and any atom with a different number of protons is not carbon. If you check your periodic table, or even if you check what we're just looking at up here, you can see that carbon atoms all have 6 protons. So again, anything with a different number of protons, any number of protons other than 6 is not carbon, but every atom with 6 protons is carbon. Carbon 12 and carbon 14 are both carbon, so they both have to have 6 protons. But the reason they have different masses here, 12 and 14, is because they have different numbers of neutrons. So those mass numbers, which again, remember that mass number is protons plus neutrons. Those mass numbers are different because the number of neutrons is different. And we're going to take a look at that. So again, just like we did on that other page, we're going to use kind of a drawing legend of like, we're going to draw protons as a circle with a plus sign in it. We're going to draw neutrons as an empty circle. And we're going to draw electrons as a dot. We're going to do that for both of these drawings. Okay, we also need to figure out how many protons, neutrons, electrons we have. So for protons, they're both carbon. We just wrote this number down. All carbon atoms have 6 protons. So I'm going to write 6 protons on both of these. We also know that right now, until we get to unit 4, we're pretending the number of protons and the number of electrons is always going to be the same because we are always going to be looking at neutral atoms for now. So if there are 6 protons, there's also going to be 6 electrons. And again, there are cases, lots of cases, where protons and electrons are not equal. We're going to talk about those later in unit 4. Neutrons is what I really want to focus on right now. So remember, if your mass number is protons plus neutrons, for carbon, we have 6 protons plus some number of neutrons. And for carbon 12, those add up to 12. So 6 plus neutrons equals 12. How many neutrons are there? There must be 6. But for the carbon 14, 6 protons plus some number of neutrons doesn't equal 12, it equals 14. 6 plus what equals 14? That number of neutrons is going to be 8. We still got to draw it. Again, I would like you to focus just on making your drawing easy for me to read or count. So put your 6 protons in some kind of nice formation that I can easily look at and be like, oh yeah, that's 6. I don't actually have to count it. I can just like see, I recognize this shape as like 6, right? Like a dice. So 6 protons, 6 neutrons. Remember, your electrons on the first ring can only hold 2. The second ring can hold up to 8. We're only trying to get to 6 total. So that's 1, 2, 3, 4, 5, 6. And for carbon 14, again, 6 protons. Just do me a favor and draw them where they're easy to count and easy to check and easy to grade. For 8 neutrons, I might do like 2 groups of 4. So again, that's easy for me to look at and be like, oh yeah, 4, 8, done, check. You don't like specifically have to. Ultimately, you're going to get it right if you have the right number of each thing. I'm just saying, like, for me, it'd be easier if you draw it in a way that's easy for me to grade. And obviously, if you draw it so sloppy that I can't read it, then you'll actually get it wrong anyway. The electrons are going to look the same here. 2 and then 4. And you can see, right, that these are both carbon, and I know they are both carbon because they both have 6 protons. If the number of protons was different, they would not both be carbon anymore. But because these neutrons are different from one to the other, that is what makes these 2 atoms, even though they are both carbon, these 2 atoms are isotopes of each other. They have the same number of protons. They're the same element, but they have different number of neutrons, so they have different masses. That's what isotopes are. You've got some practice problems here to go through. I want to point out that this one down at the bottom is a problem. You're supposed to do something, like read this. It tells you to do something. It's not just like a pretty picture for you to stare at. There is a question there. And then there's here some more problems. I'm sure somewhere on Schoology or whatever, I will tell you which problems to actually do. But yeah, they exist. So keep an eye out for that. And see you on the next video.